And welcome. Today we are going to learn about programming in Pascal. And to start with, we can start with some of the definition of terms used in Pascal. So the first term we are going to look at is what is a computer program. This is a set of coded instructions given to a computer and represents a logical solution to a problem. It directs a computer in performing various operations, tasks on the data supplied to it. A computer program is a set of instructions that will give your computer to perform a specific task. The second term is a program. These are step-by-step instructions that control and direct the computer hardware in carrying out a given task. Tasks may vary from very simple, e.g. computing surface area, to complex ones like statistical analysis. So the third one, we have programming language. This is a set of symbols that govern the rules that are employed in construction of a computer program. In programming, we have different programming languages. We have Pascal, we have HTML, we have Java, and so on. We also have Python. So the third one is source. The fourth one is source program. Refers to a program statement that the programmer enters in the program editor window, in which have not yet been translated into machine readable form. The last one is object code. Refers to the program code that is in machine readable or binary form. We are going to look at the differences between source code and object code here. So this is what you're supposed to know, that this is the code language that the computer can understand and is produced by a compiler or an assembler after translating the source program into a form that can be readily loaded to a computer. So an object code, this is the type of language that the computer understands. The difference between object code and source code is that source code, these are the set of instructions that a programmer keys into the computer. And then now we have to translate these so that the machine can understand. Okay? So with that, we progress to topic 2, where we'll be looking at program development and design. We have 7 different steps of program design. Before we come up with a program, you have to follow the steps for you to have a successful program that is going to solve a specific problem. So the first one we are going to look at is problem recognition. That is the first step. The first step, you identify the problem that you have. For example, when let's start by looking at simple programs to solve a simple task, such as calculating the surface area of a circle. So that is your problem. Okay, so you have recognized your problem. The second step now, that is where you define the problem. Also we call it problem analysis. In problem definition, the programmer tries to determine the output expected. So once you identify your problem, you need to know what output, what do you want to get from this program, okay? So the next step is program design. So this is now when you start designing the program that you want. This is the actual development of the program's process or problem-solving logic, called the algorithm. It involves identifying the process task required to be carried out in order to solve the problem. The next one is program coding. This is the actual process of converting the design mode into equivalent program. Now this is where now you start coding. You start keying the you start now converting the algorithm to a design model for the program. And here you can use different languages, but now we are looking at Pascal, so we are going to use the Pascal language. Okay, so the fifth one is program testing and debugging. once you have finished coding, before you run your program, you have to check for errors. This is where now, after designing and coding, the program has to be tested to verify that it's correct and any errors detected to be debugged. So under program testing and debugging, before you run you see your program is not going to run it. It's not going to give you the output that you need if the program has any errors. So testing is a process of running computer software to detect any errors or bugs. Debugging is the process of detecting, locating, or correcting any errors. Okay, so in every language you have a debugger. So once you run your program, once you use your debugger, it's able to detect any errors and remove them. Okay. The sixth step is program implementation. Once you have identified the errors and now you're sure that the program is correct, you run it and the program is able to run and is going to give you the outcome that you needed. You can now start implementing the program. This refers to the actual delivery, installation, and putting of new program to use. The program is put into use after it's fully tested, well documented, and after training, the staff will be involved in running of the new program. Looking at this, we can use an example of a more complex program. Yeah. So let's say, for example, you're designing a program for apparel design that you want to implement it in the company. Once you have followed all the steps, that's why now you want to implement and deliver the program to your client. You can after fully tested, well documented, now you start training. The staff will be involved in running the program. That's now what we say implementation. In Pascal programming or in any other language, we have the control flow structure of a program. Now, under this, we are going to look at 4 different structures. We have algorithms. And algorithm, let's start by defining algorithm. An algorithm is a sequence of steps which results to a plan or a strategy on how to go about solving a problem. There are different ways of presenting an algorithm. So, well, if you have a problem, depending on the program the language that you're going to use, this is where now you put down the algorithm. And there are 2 different ways of presenting the algorithm. We have pseudocodes and flowcharts. Well, we start with pseudocodes. Pseudocode is a method of documenting a program logic in which English-like statements are used to describe the processing steps. Let's start by looking at an example of a pseudocode. And in this pseudocode, we are going to use a problem where we are going to calculate the sum and average of 2 numbers. In Pascal programming, following has some rules. So you start, as you can see on your screen, you start by telling the computer that you're starting. This is where your program starts now. So start. Print is input. The input, what do you want to input? You want to input 2 numbers. So after that, the second line is input. So you input your numbers x and y. Sum, you know what you want to do, what you want the program to do to find the sum. So sum is equals to x and y. Next, average. Average is equals to the sum divided by 2. So the output, now you print sum, then you print average. So that would be your output. And then now you tell the program to stop running. Okay, as you can see in your screen, this is the example of a pseudocode. Now the next one, you're going to look at flowcharts. When using flowcharts, we have different shapes that depict different reasons for using a certain shape. The first shape is an oval. An oval identifies the process. This is the process used to represent the operations and computation. The second one, we have a rectangle, identify the start and the end of the program. The third one, we have a parallelogram, detects the input and output. The star, we have decision making. This is mostly used in decision making when you're using control structures. We have an inverted oval. This is used for connectors. To show an example of a flow chart, we have this. This is a flow chart that is used to prompt the user to enter two numbers, find the sum and average of the two numbers, and then display it on the screen. So as we can see, to start and end your program, we use the oval. We said the parallelogram is used to input the numbers that you're using to solve your problems, and then we have the rectangle, and then we have the parallelogram now to output. It's used to input and output, and then we have the oval to stop the program. We can also research on some of the examples of using flowcharts and using those different shapes. So the last one